it's more like a hands-on. So I have like a really brief overview on QML, just to give you guys, assuming that some guys haven't done any QML before, a taste of how QML looks like and what you can do with QML. Finally, we are going to discuss a set of about 9 or 10 good practices, which I believe are really important to write a portable and performant QML code. And finally, and the last but not the least, we have a final section where I'm going to discuss some examples, which I hope are advanced enough to entertain the more advanced audience. Okay, first, what is this QWidget? Well, Google, look into the Wikipedia, says that QML stands for Qt Meta Language. It's all about a new way of creating user interfaces. So I decided to put 2 examples at you guys left. There is a declarative way of creating a button and defining its properties. And at the right side, I have a more imperative way. So if you are like a C++ programmer, probably you are going to feel more comfortable doing the things on this way, like in a more imperative way. Feels more natural, right? And besides, the code size are basically the same. So what is the difference? Will this impact in the time and the effort for developing a project? Let's try to discover. Okay, so what about a case study? Here's the challenge. Let's try to build a user interface that looks like this one at the right side. Requirements: one top bar with clickable buttons, a lower bar with clickable buttons, a kinetic scrolling list in the center, and finally, and most important in my view, the user interface got to be rescalable. So you can execute it in a device with varying resolution and varying screen size. Just one question. Have anyone here implemented in C++ a kinetic scrolling list? Nope. Oh, right, one guy. Just one guy. 2 guys? 3 guys? 4 guys? 6? Oh, okay, all right. It's good. Okay, but I've implemented it in C++ and Python, and in C++ using QTimers, QAbstract animations, and I have to say that's not an easy thing to do to get it right. Okay, maybe some of you guys are going to say, well, but QML and QGraphicsView C++ are quite different. Are you going to compare apples to oranges? Yes and no. I mean, they are different, but they can be used to try to tackle the same categories of problems. Okay, which one will be more verbose? Which one will be faster to develop? Well, I really believe in numbers and hard numbers. So the next graphic, its chart shows left side the amount of lines of code to implement that user interface using C++ in QGraphicsView. And at the right side, the amount of lines of code in QML. You see, if you go with C++, even though I am a C++ developer and I have been doing C++ the last 12 years, you're going to need to write almost 10 times more code. Okay, but what about development time? Because lines of code does not tell the whole story, right? Well, I took about 1.5 days, between 8 and 10 hours to code it in C++ QGraphicsView. And on QML, I did it in like 1.5 hours. One observation, in C++, I used already available kinetic scrolling list that I coded like months ago. And I also use a basic button that featured like, the feature of scaling the background of my button. because again, the whole user interface got to be rescalable. Question, if we start a new project today, assuming that it has user interface, and you decide to use QGraphics View, and another team on your same company uses QML, which project do you think are going to be completed faster? I will leave this question for you guys to answer. All right, so what QML really means for different categories of actors? I would say that for managers, it means that probably we're going to be able to complete our project faster. For designers, you are going to have a faster interaction between creating mockups and later actually see it running on the target device. And finally, for developers, and it means that you are going to have more time to implement the more interesting parts, which in my view is not the user interface, are the algorithms, the data structures, the networking stuff, if it's a game, the artificial intelligence, the sounding system, and so on. Okay, so should I put C++ out of the equation completely? Well, some people will say, some QML diehard fans that, yes, you should. In my view, it depends. First, you need to ask some questions. First, what is the complexity of your application? C++ is really scalable when it comes to application complexity. I mean, just as an example, WebKit is written in C++. WebKit is so powerful that it can actually boot Linux kernel. Can you imagine that? And it's written in C++, and it's a really huge project. So, in my view, if you have a really complex application, you should go with QML and C++. Of course, you can also write a fairly complex application only using QML and nothing else. But in my view, it will depend also on the functionality. Does everything that your application is required to do, is it available in QML? Most probably not. So this is the moment where C++ can really save the day. Because what is really cool about QML and Qt is that you can have like a seamless integration between the C++ part and the QML part. You can have like a model view controller pattern where you have the models and the controller in C++ and only the presentation layer on QML. Or you can write also C++ plugins, export your own types to the QML context. So there are so many different ways to do that integration. And finally, it will depend on the team. I mean, if I only have like in my team people who don't actually are good C++ developers, should I try to use C++? Well, maybe not. But if I have like some good C++ developers, I would try to use some C++, and I have a comment. If you are able to write C++, basically you are able to code in anything, and QML will be just a piece of cake. All right, what about QWidgets? Whenever I talk about QML, people always ask me about QWidgets. Yesterday I decided to look into Qt Creator, the amount of widgets available. You see that I have some KDE widgets here, but I haven't included them now. But only look at those widgets. I counted something like 96 widgets. I dare to say that it's quite a huge amount of widgets. So, relevant questions. What your application really needs? Is it good if you have like just, checkbox, list view, combo box? buttons. If you need all that, then QML can be the right answer. If you need fairly complex widgets and you have a good team, you can still use QML and write your own widgets. I'm going to show later in the second part of the presentation some examples. But if you have like some requirements for really, really complex widgets, then it might be interesting to stick with QWidgets for a while. I mean, they are going to be supported in Qt 5. If you can wait to Qt 5.1, then it might be interesting to have a look on the Qt QML desktop widgets. Yesterday, a guy from Digia, I forgot his name, he gave a really impressive presentation about Qt desktop QML desktop widgets, where in just 20 minutes he was able to implement a fairly complex user interface, just reusing the widgets available. And finally, do you need animations? If you need to have animations, then go for QML. If you don't need animations, well, QWidgets may be able to do the work just fine. And finally, I believe this is a really important question is, do you have a graphics artist, a graphics designer on your team? Because, you know, I'm a programmer. I'm basically terrible at trying to draw anything. But yeah, fortunately, we work with designers, and they are the guys who know about user interaction, how to have a good application workflow, how to create icons, and so on, so on, so on. Honestly, I believe that in this day, even for pure desktop applications, you should have a designer on your team, because those guys, they know their stuff, and they can really contribute back to your application, and thus to your success. Final comment about this subject. Use the right tool to the right job. All right, so you decide to go with QML, but you don't know QML. How you can become QML proficient? If you are a student, it's really easy in my view. Well, first, use the power of the open source. QML and Qt has great online documentation made available for free. Qt itself is open source. And finally, there is a wonderful community with a wonderful project called KDE, which is a whole desktop. It's a whole environment built on top of Qt. If you are a student and you have some talent, you can work with KDE, you can learn. And you may also be part of something called GSOC, that's Google Summer of Code, where we are going to work on this summer. You are going to get paid for doing that. You are going to get paid to writing open source software, which in my view is like the best of the world. As a matter of fact, I think it's important also to share this lesson with the students. Making mistakes is part of the learning process. You should not be afraid of making mistakes. Whenever you try something new, it may work, may not. Finally, the one who makes more points is also the guy who is going to make more mistakes. I only know one category of people who never makes mistakes, the guys who never try. And finally, while learning, look for the best. We live in a connected world. It's such a beautiful time. The distance between your desk and sometimes the best creative minds in the world is one click away. Okay, time to relax. I have a confession to make. Do you know why I have this KDE button close to my heart? Because as a matter of fact, I learned how to write Qt contributing to KDE. So, and I dare to say it worked pretty well. All right. Imagine that you are a professional, you are a manager, and you have the resource, you got the power. What is really beautiful about Qt when it comes to training is that you have a real ecosystem. You have ICS, that is USA based, even though we have several developers here in Europe. We have KDAB, that is like a primary hoster of this event, that's based in Germany. Also have DGIA, that is based on Finland, and they have recently acquired, merged with Trolltech. And finally, there is Collabora, and I could continue the whole day telling about different companies in different places that have some cute, good developers who can train you and your team. But what happens if you need to have Qt power, if you need to develop a project today? Well, good news are that I know some people who can help you. So if that is your case, we should talk later. All right, QML 101. What are the QML elements? I have some visual elements, positioners, repeaters, views, utility animations, models, and so on and so on. But so many names, I'm not going to read all that. Which brings me to one fairly important subject that we lack the time to cover it all. But I just noticed that I still have some time available for my presentation. Is this the end? Not. I have the second part. All right. Let's see. Okay, second part. Okay, QML basics. All right. Dear people, I present to you the rectangle. It's one of the elements available to QML. And if I move my mouse over here, gosh, there you have it. Say hello to Mr. Rectangle. So imagine that I want to make it bigger. And I want to change it to red. And I can also, there are so many properties. And so on and so on and so on. Okay, maybe you are asking, how are you able to execute QML code in line inside of your slides? Answer, this is also a QML application. Of course, I got to write my own C++ plugin, I got to patch Qt5 and hack some stuff to make it work in line, but you see, I think it's all about dog feeding. I run KDE that is based on Qt. My slides are also QML. So if you believe in something, you should really use it. All right. So this is the image element. I'm not sure if it's going to work, but you can also load resources from the internet. What's cool is that you can also have like, if you use C++, you can assign a QNetwork manager with a cache so that you can cache the networking results. What's cool is that enough of Google free advertising. You can scale the image. And you can tile the image, you can rotate it. You can, for example, make it translucent. Oops. It's really tough to... opacity. No, I made it on purpose. It's all about engaging the audience. And then it's translucent. All right, then you have the text element. You can also use true type fonts here. You're not stuck to the fonts available on the system. As a matter of fact, when it comes to deploying, you can have your fonts available on the system, or you can also have it inside of your C++ application if you are using QResource. So, and you can also change the size and so on and so on. This is the editable text. And I'm not sure if the source code font size good enough. Are you guys able to read it? Yeah. So since we are in Germany, hello, my Freund. All right. Put it all together. What about create our own widget, the button? Generally, when it comes to QML, the hello word is a button. We have some new stuff here. I have something called property, where I can have some properties of my object defined, which is the preferred way of defining interface when it comes to QML elements. I have another guy called mouse area, where basically I'm able to handle mouse events. So that if I execute it, here I have a clickable button. Isn't that cute? All right, so the basic idea is that if you write good components, you can use it in basically any place. This is a calendar widget. It's using only the basic elements and some JavaScript. I coded this calendar widget for my application, Cellar Door, that is like a wine journal. And I wrote it like almost 2 years ago. And at that time, I could never imagine that someday I would give like a talk here in Berlin and put my widget inside of a slide. But since I found a good approach while writing my widget, it doesn't require any change to make it work on this fairly different context. All right, what about kinetic scrolling list? You know, iPhones made the whole idea of kinetic scrolling really popular. What's good is that with QML, you'll get it for free. You don't need to code it in C++, think about timers or about animations or about friction or about attenuation of speed and so on and so on. You only need to define a model where you're going to have the data with the number of elements and the properties of the elements and the delegate that tells the list how to paint the data. So this is how you create a basic scrolling list. There is a component called list view. And then I have it. You see that the scrolling list is being painted outside of its area. Why? Because list view will cache the items outside of the viewport, so you can have a smoother scrolling. Say that I don't want to have it anymore. Where is my cursor? All right. Can just enable clip. True. And there you go. Whoa. Oh yeah. There's a typo there. No, I need to implement inline syntax check on my slides. True. Okay. So only the height will have visible items. It's really cool because you can also tweak the value of the amount of items that are cached on the list view. That can help have smoother scrolling. All right, this is my delegate. It's a simple image with text. This picture value is being retrieved from the model, as also type and age. So you see I have type dog, age 5. I'm using JavaScript here, which is important to comment that delegates should be as much efficient as is possible, because you're going to have several delegates. If you are scrolling, you are going to have painting operations. So you want to have a better scrolling list view. You need to give some thought and you need to give some love about how your delegates are going to be implemented. Finally, the list view model. Here I have a list view with a list elements and I define the properties. But is that everything you can do with a list model? Well, actually you can exploit them. Have you guys seen ICE's demo running on the booth? Have you wondered how the tiles, the scrollable tiles, were implemented? Well, I would invite you guys later to visit, but I can tell you that you can also pass geometric information inside of a model. You can do even more. Why not supply, say, custom code like custom JavaScript information within the model? I mean, your imagination is the limit. Okay, third part. Maybe you guys are wondering, what is this little thing over here that looks like a clock? Well, it's a stopwatch. So I can try to track how far the progress is going, which I think we need to speed up a little bit. All right. Okay, coding style. Coding style is something really important. You see, this code is so horrible that hurts my eyes just to look at it. We have horrible coding style, wrong indentation. It's not making the good use of setting attribute values, and I could go about it the whole day. And this is how you write better code. There is a document that describes QML coding style. I highly recommend you guys to read it. Okay, what about internationalization? There's something called QString. When you put that on your QML code, there are some Qt tools that enable you to extract those strings, and then you can do internationalization of your application. Yes? Okay. Well, my pet project, Cellar Door, feature is a QML application, Qt QML application, C++ application. The feature is internationalization for, I think, 6 languages: Portuguese, English, Spanish, Italian, German, French, is something else. Later, after my presentation, I can show you how it works, and we can discuss the subject further. What? You see, if you have like, just to give an example, the internationalization is not perfect yet. If you have like a fixed model and you have some strings within this model and you want to internationalize these strings, it's not going to work. Tricky question. All right. Another thing I believe is really important. Your application, assuming that it has like a C++ app that launches it, should also run fine within QML scene or QML viewer. In the case of Cellar, over here it's running inside of my C++ viewer, and over here is running inside of QML scene. if you just take a little care while defining the uh, source information, the URLs to the images, you can accomplish that fairly easily. As a matter of fact, once I was in a project, we have our own C++ application. We have been working on it for 2 months and a half. And on the last sprint, the sponsor came and said, well, I don't want to have a C++ application. Should run inside of QML viewer. If we were not careful about designing it on the right way, we would be in trouble because we would have like 2 days to fix the whole application. But since we have done that right since the very beginning, it was not a problem at all. Just like they say, fortune favors the prepared. All right, avoid unnecessary items. What is wrong here? I have like component, an item, an image, and a text. You don't need them now. You can do exactly the same thing with an image and a text. So even though item was not supposed to paint itself, avoiding unnecessary items is always a good idea when it comes to optimization. All right. Another thing I believe is really important is that not only widgets, but subsets of your window should be self-contained. Why? First, improves modularity. Next, helps you to have different components, different people on your team developing different subscreens. Finally, it will allow you to do something like this. This is one of the cellar door subscreens. And I can put it inside of a slide. I can select the type of line, and so on. Even though it was never designed to run inside of a slide. For doing this, you need to do some tricks like make sure it's going to be resizable. Try to have some dependencies within your own widget or within your subscreen. And if you don't, you can test against stubs. And finally, you can also have some properties like imagine that you have a C++ controller. It's ported to QML context. You can have something like property myController ... controller. Supposing that you would require that to work, you can have something like if, I don't know, myController equal undefined. Okay, then use the stub control. It's doable. All right, use properties to, when it comes to object-oriented programming, I think it's really important because JavaScript itself is it's a lacking language. And you should use properties to define access to your widgets. You should also try to keep the software modular. And if you need to access something within JavaScript or a QML widget, you should define an interface for doing that. Of course, you could just write, I don't know, my widget dot item dot visible equal false. But that is a layer violation. It's not a good programming paradigm. You should instead have something like my widget set to not visible, or either using a property or having a JavaScript function. All right, so widgets should be encapsulated. Never, ever access parent item within a children item using the ID. Why? Because if I move this children screen or this children widget outside of its original parent, it's going to crash. It's going to fail. And I have seen some QML code written by companies where people did exactly that. So I was supposed to refactor a simple button that was within a screen. I changed this button, then the whole application crashed. It no longer worked because it's like this parent window was referring to this item to the ID. The ID was being referred backward, and there was like a bigger screen that also was referring to the ID. I mean, we can do better than that. Oh yeah, and one last thing. Complex apps benefit of having a C++ application. All right. Okay, beware of the overuse of list view. Sometimes you will have some applications where people are list view happy. They use list view for everything. There are other repeaters. Actually, there are other elements that you can use, like the repeater. And if you have just 2 or 3 items, maybe, if you are running embedded, you should avoid having the weight of a model and a list view or a repeater and all the code associated around this. Maybe, actually, generally, will be faster just to put like the 3 items, like hard-coded. All right, it's quite common that people are going to have like 3 or 4 QML files, and all the items are going to be created in one go. So, this is bad, increases memory usage, performance is horrible, especially if, for example, have a web view with a WebKit, it's pretty heavy, so you should use loaders. All right, last part, QML tricks. I'm so sad because this, in my view, this is the most interesting part of the presentation. But I only have like about 10 to 15 minutes left. So if you guys have want to learn more about these techniques, we can discuss it further after my presentation, having some coffee. All right. Well, any moderately complex application are going to have several models. So it's quite common to have like 3, 4 different models to represent different views. Imagine if something like a media player. You can have like a model for representing the catalog, another model to represent the tracks within an album, and another model to represent the tracks, I don't know, like selected tracks, and so on, so on, so on. Having to code in C++ again and again and again, several different models is quite boring. Fortunately, there is a way to work around that. You see, assuming that the data that are going to represent is a QObject, and assuming that it has its properties defined as QProperties, QObject has methods, so you can inspect the data within the QObject. So I could just have like a class, say contact, with 2 data, say name and telephone, and I could have I don't know, a generic list model using pointers, but you see, when you assign an element within the list model, you need to copy its contents. Generally, we are going to have like a QList inside of the list model. And if you don't know the type beforehand, say I have this contact data and I have the track data, how am I supposed to know how to copy the data? How am I supposed to know how to allocate an instance of this object? Because my generic model does not know that. There's something called templates in C++, so I could just have my list model have as a parameter the class type, and then you should be gold. You would not need like pointers. Your generic model would work fine because at the time of compilation you could have access to the type of data, right? But there is another complication. You cannot have QObjects with templates, right? So there is a pattern called proxy pattern. We have ancestor. This class inherits from QObject. This class is not a template. You can have slots and signals in this class, right? And then we have another class that is a child of the first class, and this class is a template. So you can work around this limitation about QObjects and templates. But what happens when I need to implement, say, the append method in a model? I want to add a new object within the model. Well, this is another interesting feature of C++ and Qt. What is a slot in C++ and Qt C++? It's just a function. So you could just mark this method as a virtual function and set it as an abstract method, and on the class that is the template, we re-implement this method. Yeah, it took me a couple days to get it to work, but end results that you can have like a generic model that's going to work with any QObject type, which means that you never need to write a model again. Okay, but the class itself uses some nasty tricks, and I only have 10 minutes. And I have still 4 other examples. I will try to cover the other examples later, try to show the code, but if you guys don't trust me, I can show it running. Oh yeah? Okay, I can try to show the code later. Right, but so basically, if you want to create a generic model, it is possible, but you need to do some nasty C++ and some nasty Qt programming, but it's possible. Another thing, there is a technique I call time-delayed load and painting. What is the basic idea? Imagine that you have like a really well-behaved QML application, but you are running a really slow hardware. How slow? Think about 266 megahertz. This little fellow, the geode, it's used commonly in embedded space, as an example of Unix. And it may happen that even if you have a loader to load the next screen, assuming that the CPU is low, I don't have any kind of hardware acceleration for painting, the whole application will lock for 3 seconds. What can you do? This is the basic idea of time delay load and painting. You turn all the static elements, say rectangle, text, and so on, image, whatever, into components. It can be done within the scope of this very same file. Next, you need to have associated loader to each one of the visual components. Finally, you push them to a queue and have a timer that is going to control the dispatch of getting a loader, associating a component, and painting them on the screen. So in this case, your application will be able to load the next screen, but the application will be still responsive because you give enough time to the Qt event loop to process the key inputs, because you are not trying to do everything in one go. You are painting like an image here, a text here, something else here. If you think, this is quite similar to the way that a browser works. You don't paint the whole page in one go. You paint one element here, another element here, and so on and so on. But in the case of the browser, the limitation is not processing power. Okay, maybe processing power, but it's bandwidth. In this case, it's CPU processing and the speed of painting. All right, any of you guys know what is OpenCL? Ah, quite a lot. OpenCL is a new standard. It was basically defined by Apple. The Cron's standard group defines what goes in, what goes out of this standard. And you can think about it like the standard way of executing general code within GPUs, CPUs, or whatever hardware. It's really cool because the syntax is really close to C, and it's like hardware agnostic, because before that you could have like shaders, you could have like a general programming on GPU using proprietary language. So NVIDIA has CUDA, ATI used to have something else, and so on and so on. With OpenCL, you can have code run inside of the GPU or the CPU, and this code is going to be portable. So I wrote a small demo where basically I defined an OCL element. I think this should be called something like a QtLabs OpenCL, but at my demo I'm calling it con.ics.something else, where you could define like the kernel of your OpenCL program as a source attribute. Actually, the source of the program as an attribute, and the kernel, which is the function you want to execute. You could, for example, activate the execution that basically is going to compile the kernel, send the data to the GPU and retrieve it back as an active property, and get the data back as on ready or something like that. So it's just a proof of concept. I talked with Lars about this idea and Thiago Macieira, and we will see what this may become. All right, Dbus. So here we have Dbus. I learned this joke with John Palmieri. All right, what is Dbus? It's message-based. It's like the standard way of IPC and RPC on Linux. It requires C++ because at this moment there is not like a QML integration with Dbus. Okay, issues while running embedded. You have latency, you have the issue of CPU usage because you need to marshal all the data back to the Dbus. So one way to work around that is that, say you have 2,000 items on your Dbus server. You need to show all those items into a QML application. And you are going to do the communication between both processes using Dbus. Instead of sending all the 2,000 items in one go, you can, if your user interface is going to show, say, 7 items, you send small batches of 9 items. So the model on the client is going to be updated, but you start to receive the data right away. Instead of, imagine the user interface. You click on the button like get the data, and having to wait until something shows up. You click on the get on the data, you already have some visual items on the user interface. I also prepared a nice demo here showing the technique. All right, and the last subject. Who here have serialized data using Dbus on Qt? Anyone? Come on, guys. Not a single guy have used Dbus ever. Oh, okay. But the whole idea is that if you have a string or an integer or something simple, not a problem. Just send it to the Dbus. But let's return again to my example, the music application. We have within a track object something like a duration, artist, album, year, and so on and so on and so on. So I have several different types of attributes. To send this object through Dbus, since it's message-based, you need to marshal this data. For doing that, you need to write an operator in C++, a string operator. And whenever I need to debug a Dbus C++ application, first thing I do is to look on the operator, because people do that wrong all the time. Well, writing the same code again and again and again is so boring. There is a way to write like a generic marshaller for Dbus. You just use a string and returning to the example of a track object. Imagine that I have like a list of track objects. You can use the QObject meta introspection to retrieve the properties, and just put that inside of the string as a JSON object. So you still have like a code that is capable of marshalling any type of data, provided that is a QObject, so I can inspect the attributes. And at the same time, you still have the complexity of the mapping between each attribute and its object, because that is represented as a JSON string. I have done this before. It works pretty well. Just writing the marshalling, or write the marshaller once, and then you are done for your life. Never need to write a marshaller again. All right, so what's next? Well, first, there are some people I would like to thank. First, I says for sponsoring this presentation. Next, Alan Azurs, that's like my partner. I have been working with him in some projects. Gunnar Sleta, who created the QML presentation system that I'm using on this talk. And Vladimir, who coded the widget, the stopwatch widget. Final Dev Days organization. This is my second Dev Days. The first one was in 2008, California. So far, I'm really enjoying the conference. And I think everything's so organized. And finally, Qt for existing such an empowering tool. So, some reference. Alan wrote this book, Qt Design Patterns. And we are working in a book or training course or document or whatever called Effective QML. And finally, my last message is enjoy the ride. Be smart. And using Qt and QML, we're going to have more spare time to do some interesting stuff. And most important, use some wicked hardware and software. I mean, if you are going to work, target for the best tools. And Qt QML is one of the best. All right. Questions?
Thank you, Adenilson. Any questions? Yes, over there.
Hi. Question about Dbus. Is it possible to access Dbus purely from JavaScript, or do I always need C++?
Yep. So
QML is dynamic, so I could imagine it's possible to choose.
Yep, it's a good question. Just like I commented, QML at this moment doesn't have a ready-to-use Dbus model. We need to have a C++ application and a C++ object. You can create, for example, an interface, say a slot, that is like a call Dbus method. Export the C++ object to the QML context, or write a plugin. Then you can, on your QML code, do something like, imagine that is a plugin. Import like a foo.com dbus helper, and then dbus helper, and then you can invoke the method, say, send a message or invoke method. Or if it's like a C++ object created in the C++ side, you can just export the object to the QML context. Then inside, it's going to be like a global object. So all QML files on your application should be able to see this object and invoke its slot. Which is a good question. I wonder if there are plans from Qt guys to ever provide a dbus, like a standard way for QML. But at this moment, you need to use C++. Questions? Come on, guys, don't be shy. Yeah, I was going to say, well, how many time do we have?
A couple of minutes. 5 minutes?
5 minutes, all right. So I try to be fast. All right, you try to rotate this because I'm starting to have a headache. Actually, a neck pain. Okay, here we go. Where's my cursor? Dear God. All right, demo time, finally. All right. So which one do you want to see first? The generic model? Right. So the generic model was cooked together with the dbus example. Let me see, Qt5. So I will start the dbus server. All right. Then I go into the UI, and it's a Qt5 application, but the same technique works just fine on Qt4. What the fuck? Well, okay. All right. Okay. So this is a normal request. I have like 2,000 items, all right? Sent in one go, and this is the request using small batches of data. If I plug into the Dbus, I'm going to see small patches of data being sent. All right, where is the generic model? Okay, I told you guys that I have like a base. By the way, this is GPL code, so you can use it. So this guy inherits from Query Abstract List model, all right? It has the methods used to insert new items and remove items in the model as slots. Some of them are implemented as abstract functions. And on the generic model, I inherit from it, and it's a template class. And here I have the real implementation of the stuff, say add. Add item goes here. All right? So how do you use it? Okay. Controller. Okay. Just do something like this. My generic model, new generic model, and the template parameter is a complex data. The complex data is a Q object, and it has two properties, but I could have whatever number of properties of whatever type. All right? Okay, so this is cool because it's like the Dbus batch trick together with the generic model stuff. Let's show the OpenCL guy. It's a pretty cool demo, I think. QML, nope, no, it's not this one. Where is it? Dbus, frame CPP, OpenCL. All right, this you have it. Okay, my notebook has Optimus, which technology where I have an Intel graphics and NVIDIA graphics, so I need to use Bumblebee to execute the code using the NVIDIA. So this is why I have like a run script that's going to export the path and call optirun QML syntax QML. Oh yeah, Qt5. All right, takes a while. All right, actually this is pretty cool because you see the C++ code is testing for the number of devices that supports OpenCL. I have one, that is NVIDIA. It implements OpenCL 1.1 profile. It's a GeForce, and it runs on top of NVIDIA CUDA. This is my kernel function, okay? It's a really simple one. It's just going to calculate the square or the power 2 of two large vectors. And then I click here, and it calculates. Question, how many cores I'm using to execute this? I mean, this is an Intel i7, right? I have like 4 real cores and hyperthread 8 cores, right? Okay, but I'm running the execution, the GPU. How many cores? 8? 16? 32? 64? 128? Yeah. I think I'm using 1024 cores. This is why I think this is an interesting idea, because if someone comes and say, oh, QML code is slow, and I'm going to say, well, you can be faster than this. Like, show me a computation that's going to run faster in pure C++, then it's going to run faster than using OpenCL. Okay, of course, this is like an editable thing. So if I edit my, what? For some reason, yeah, this is like, I mean, I cooked this while flying all the way from Brazil to here, so it's not really production ready. Okay, and I think we still have time for a last demo. Nope. Ah, what a shame. All right. Well, so thanks everyone.
Yeah, thanks, Adenilson. And also thank you to the audience.